So on the notes, it says that raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous solutions. So when you use this procedure, you should always check each apparent solution in the original equation to make sure that it works or both works or, whatever the situation is. So let's try this example here. We have x plus 1 equals square root of 7x plus 15. Now I really can't move anything around. I have the radical isolated already, so really the only thing I can do is to square both sides. So this is a binomial squared. So this is x squared plus 2x plus 1 equals, on the right side, 7x plus 15. Whenever you get a quadratic, you just want to set it equal to 0 to solve. Or at least when you have an a squared plus bx plus c. So let's subtract 7x from both sides and subtract 15 from both sides. So this is x squared minus 5x minus 14 equals 0. And this is factorable, right? So negative 14, when multiplies to negative 14, that adds to negative 5. That would be negative 7 and positive 2. So this factors to x minus 7, x plus 2 equals 0, or x equals 7 and x equals negative 2. So we have to, of course, check our solution. So let's go ahead and check negative 2 first when x equals negative 2. So negative 2 plus 1, does that equal the square root of 7 times negative 2 plus 15? So this is the square root of negative 14 plus 15. Negative 1, does that equal negative 14 plus 15? So negative 1 equals 14 minus negative 14 plus 15 is square root of 1, and that's just 1. And so negative 1 does not equal 1, so that is not one of our solutions. So let's see if x equals 7 works. 7 plus 1 equals the square root of 7 times 7 plus 15. 7 plus 1 is 8, equals the square root of 49 plus 15. 8 equals the square root of 49 plus 15 is 64. So 8 equals 8, so that does work. X equals 7 is our solution. So solving an equation with two radicals. So it does a little bit more work on here, but we can still do the same process. Looking here, if I subtract 1 from both sides, it doesn't change anything for me. If I moved over if I set it equal to 0, that would make it messier for me. So this is actually the best form to do the work in. We're going to go ahead and square it as it is. This is our squared binomial again, even though it looks a little different with the square root of x plus 2. So we're still going to do the a squared plus 2ab plus b squared. So a squared, that just makes that x plus 2. 2ab is plus 2, and then the a, square root of x plus 2, times 1, so I'll write that just to have it there, plus b squared. Then on the right side, that just gets rid of the square root, so it's just 3 minus x. So we have 2 and 1, so that combines to make 3. X plus 3 plus 2 square root of x plus 2 equals 3 minus x. So again, we need to isolate the radical. So let's subtract x. Let's subtract 3. Okay, the 2 is multiplied, so we can't move that by adding or subtracting. So now we have 2 square root of x plus 2 equals 3 minus 3 is 0, negative 2x. Let's divide by 2. So now we have the square root of x plus 2 equals negative x. We have the square root isolated, so let's square both sides. This becomes x plus 2 equals x squared. So we have a quadratic. Let's set it equal to 0. 0 equals x squared minus x minus 2. And this is factorable to x minus 2, x plus 1. And yes, x equals 2, or x equals negative 1. So let's try it out. Let's try it out in the original problem. To check for extraneous solutions, let's check out x equals negative 1. So square root of negative 1 plus 2 plus 1, does that equal the square root of 3 minus a minus 1? So this becomes the square root of negative 1 plus 2 is 1 plus 1, so 1 plus 1 is 2. And then this becomes square root of 3 plus 1 is square root of 4, or that equals 2. So x equals negative 1 does work here. So let's try the next one. X equals 2. Let's see if that works. So we have the square root of 2 plus 1. Does that equal the square root of 3 minus 2? So 2 plus 2 is square root of 4 plus 1. And 3 minus 2 is square root of 1. So this is 2 plus 1. Does it equal 1? No, 3 does not equal 1. So therefore, x equals 2 is an extraneous solution. Our only solution is x equals -1. Try out these next 3 problems on your own, 5, 6, and 7, and then the next video will have the examples there worked out for you.